Hi, so in this video, we are going to go through pressure in fluids, which is part of topic 8i. So firstly, to discuss pressure in fluids, we need to understand what is pressure, but also what are fluids. So fluids are substances that can float. So we're talking about things like gases and liquids. If you think back to doing the particle model, we know that gases and liquids are free to move around. Liquids are still touching, but they can move over each other, and gases are completely separated, moving around randomly in different directions. Pressure is a measure of how much force is acting on a particular area. You might remember from year 7 that the equation for pressure is equal to force divided by area, where we measure pressure in pascals, which is PA, or we can measure it in newtons per meter squared because force is measured in newtons, and we're dividing by area, which we measure in meters squared. So we think about some examples where pressure might be found. We can think of a hammer being used to hit a nail, and we can think of pushing a push pin into a board. So there's a force being applied over a particular area, and therefore we have pressure. How do fluids create pressure? Well, if we look at this diagram on the left here, we can see these gas particles in this case are moving around randomly. Sometimes they're colliding with each other, but more importantly, what we're interested in is when they collide with the walls of their container. So the container in this case is the box. And when they move around randomly, they collide with the walls of the container, they're going to exert a force. So if we look at this diagram here, we can see these arrows are showing the force that is being exerted on the container walls. Now, for one individual particle, this force is going to be quite small. However, remember, we've got lots and lots of particles all doing this. So this force is going to add up. If we have a force acting on a particular area, we know we are going to have pressure. So this is how pressure within a fluid is created. Remember that a similar thing is going to happen when we have a liquid. However, in a liquid, the particles aren't moving around like this, they are moving over each other while still touching. So, what happens to pressure as we go deeper into a fluid? Well, the deeper you go into a liquid or a fluid, the greater the pressure that will be exerted on an object. The reason for this is as you go deeper, there are going to be more liquid particles that are above you. More particles above you means there is more weight, which is the force due to gravity, which will be acting down on you. If there is more force acting on you, there is going to be more pressure. If we look at this example here, this is something called Torricelli's tower. At the bottom here, with high pressure, we've got this much water above it. However, at the lower pressure section at the top, there is less water above it, so there's less force, less pressure, and so you get a weaker jet. So the deeper we go, the more pressure there will be. The opposite is going to happen the higher up we go in a fluid. For example, as you go higher up in the atmosphere, there is going to be less pressure because there are less air particles above you, so less weight, so less pressure. Let's try and apply this to an example. Here we have a crisp packet. We need to explain why it has done this. Why is it expanded when we've taken it up a tall mountain? So we're going to need to know and state some things. We need to say, well, what's happening when we first seal it? What's happening in terms of pressure as we go higher? And then what's going to happen because of pressure? So firstly, when we seal this bag at sea level, there's going to be a certain number of air particles in the bag. These particles are going to be colliding with the wall of the container and they're going to be exerting a pressure. However, there's also going to be particles on the outside of the bag that are exerting a pressure on the outside of the packet that is going to be pointing inwards. And because they're equal, nothing's going to happen. As we go higher, though, we know pressure will depend on the weight of fluid above. And if we go higher up a mountain, there is less air, and so the pressure outside gets less. Now, that means there is more pressure inside, which is pointing outwards, than less pressure outside pointing inwards. Since we have more pressure inside pointing outwards, this bag is going to expand. The opposite would happen if we went deeper into a fluid, because then the pressure outside would become greater and it would point inwards more, and so it would be squashed. So let's review some key ideas. Feel free to pause the video if you want to have a go at this before we go through the answers. So we know fluids are liquids or gases. They are not solids, they must be liquids or gases because they can flow. Solids, remember, cannot flow. Pressure in a fluid is caused by the forces from particles hitting the container. Car tires have high pressure inside them because they have more air particles inside them. So when we fill up a tire, we're putting more air inside, which means we're getting more collisions, which means more force, which means more pressure. Air pressure is the same in all directions because remember, these particles within a container are hitting off all the walls of the container, so all pushing out in all directions. Again, feel free to pause the video before we go through these. So a submarine needs to be stronger than a ship of the same size because there is more water pressure at the bottom of the sea. So that submarine down deep in the ocean will be experiencing more pressure than a ship on the surface of the ocean. Which graph shows how air pressure changes with height? Well, we've not actually told you exactly how it changes. However, we know it can't be B or D because we know that pressure does not increase with height, it decreases. Same for C. It can't be this because this is showing that as we increase height, pressure isn't changing. The only one that shows pressure decreasing as we increase height is A. It doesn't matter that we don't know exactly how it changes. We don't know, we haven't taught you yet that it is this curved line. However, we know this is the only case where it is being decreased as we go higher. So, in summary, pressure is caused by the force exerted when particles collide with a container wall. As we go deeper in a fluid, pressure increases because there is more particles above us, so there is more weight. And remember, more weight means more force, which means more pressure. The opposite happens the higher up in a fluid we go. When outwards pressure is greater than inwards pressure, the object will expand. And the opposite is true. If inwards pressure is greater than outwards pressure, the object will be compressed. And that is a brief overview of pressure in fluids.